Right, this is the chassis for my rotary actuator. I've already mounted a big bearing on it. This is the pillow block for the chuck that's going to be used to tap threads into plastic. This is the gearbox bracket. So this is the planetary gearbox from an old electric screwdriver. It's got a hex drive, and there's a plate in here and these two rods. So the plate holds the gearbox in there, and these two rods are supposedly holding the plate, but they're not touching it. So I made a little retention clip that goes between the two rods, and then I can rotate it so that it's underneath the two rods, and that positions the plate properly. And then I've got a little clamp on top here with a couple of screws in it, which I can screw down. Alright, so that holds everything in one place, and I have to screw this down. And these rods can still slide out. So once I get this screwed down, I can show you how they get retained. So those two rods can slide out of this housing quite easily. I have to get them in the housing like that. Okay, now once they're in place, I can slide them into the chassis here, and this ring prevents those rods from coming out. So if I slide this in this way, get those rods in place. There we go. Now the rods can't come out, the plate's in the right place, and this is positioned properly. So now we have the chuck, and there's a big story behind this. The chuck did not fit into the bearing here. However, I have a friend who's got a machine shop, and he turned this down. It was only 0.4 millimeters too large, but that's way too large to jam in there, so even with freezing it and everything. So he turned it down, and now it fits perfectly. Big favor from Graham. It's so tight, you have to get it in perfectly square before it will even slide in. There it goes. Now, to join the two together, I have to have an adapter, because this is a square drive and this is a hex drive. So that's how that goes. Now before I tighten that down with these set screws in the front here, I have to put in the motor. Now another thing I had to make was a shaft to drive this planetary gear. Now it has a little flat on this end, and it's a 2 millimeter shaft, and I made it from an old bicycle wheel spoke. And it just goes in to the gearbox, and then there's this coupler which is 2 millimeters to 5 millimeter adapter, which goes on here. Well, I won't tighten that on yet. And the motor goes in the back like this. So there are screws to hold on the motor. So it's a NEMA 17, standard motor size, with 4 screws on the face. that in place before we get all the couplings tightened down. So it took a long time to design the chassis for this thing, much longer than it takes me to design the electronics. A lot of measurement and just hoping that it's going to all work out. Okay, the motor is in place. Let's see if it lines up here. I have to be careful to keep the shaft of the screwdriver in place. Oh, there it goes. So there's a flat on the shaft of the motor, which was hung up on that screw. There we go. So that's the motor coupling tightened on. And now let's tighten down the shaft for the planetary gears. Alright, so that's all tight. Now I've got to tighten down the set screws on the bearing. Alright, so all tight. I just want to really check this screwdriver thing again. It's a blind fit onto the flat side in there, so I have to make sure I got it right. Okay, so it is turning everything properly. Now, to hook it up and demonstrate that it does drive nice and quiet. There's no extra friction in the system. And that's how it goes together. So now, of course, ultimately it's going to go on top of the linear actuator. But I have to thread all these holes, and I just might use this thing to thread them. Even though I'm not going to have the full drive, I can still use this to rotate the tap. Alright. So, let me get a picture of this for posterity. Okay, I have hooked up the thread tapping subsystem to the Landungsbrücke motor controller from Analog Devices, and we're going to see what's going to happen when I turn it on. This is the stepper motor and the brass coupler to the shaft that drives this planetary gear system to reduce the speed dramatically and increase the torque. This is an adapter to the chuck to drive from this hex to a square drive. And then there's this thrust bearing pillow block and the chuck that's holding the tap. And I'm going to clip on a little clamp here so you can see the actual chuck turning when I turn it on. So here goes. And you can see it spinning here, and it's vastly reduced here with much increased torque. And let's go the other way, see if that works. Yeah. So definitely not as fast as it could be to, thread a hole, but this allows me to get a lot of torque, and since it's automatic, I don't need to babysit it too much. Now, of course, this gizmo will be going on top of the linear actuator so that the tap can go forward at the same time as it's rotating, and this will be bolted on here like that. I haven't really set up the linear actuator speed, but you can see that it moves just fine. I'm going to have to slow that down dramatically, but that's easy enough to do with a stepper motor. And I still have to thread all these holes in here to bolt this down, and I might actually use this tapping system to do that. But let's get this video on the internet to show some progress. One other little bit of progress I wanted to show is the controller. So I've mounted it on a GoPro chassis. So we've got this GoPro that allows me to adjust the angle, and of course the hockey puck base. So now it's not going to wander around, and I can position it wherever I want, and it's at the right angle to get a good video shot of it. So this is a demonstration project, and we want to keep this out in the open so it can be seen. So here's the USB connector and the two motor controllers, power, and if and when I hook up the encoder, it'll go into one of these encoder connectors.